Welcome to this tutorial video. This is the third video, the third question in the tutorial series under static equilibrium, and this is question 9 in the tutorial sheet. This is a question I left you guys with last time. I believe you went through it. If you did not, pause the video and go through it. Alright, so in this question we are told to say 172 centimeter tall person lies on a light massless board which is supported by two scales. The scales, one is under the head and the one is beneath the bottom of her feet, and the scales read 35.1 and 31.6 respectively. Alright, and we're told to find what distance is the center of gravity of this person from the from the bottom of her feet. Right, so somewhere there. Okay, so consider one condition of static equilibrium. In this case, the torque, we'll consider the summation of torque to be 0, and to set this part to be our pivot. So we want to consider the forces that are working at this point. So this will be our pivot. All right, so we're trying to find the center distance, the distance on center of gravity of this person from the bottom of our feet. So our equation will consider the condition of torque. So summation of torque is equal to 0, and we'll consider the force of the scales, the two scales. The first scale is 35, the force will be 35.1 times 9.8. that will be multiplied, since torque is force times distance, that will be multiplied by the 172 centimeters away from the pivot. Converting the 172 to meters, that is simply 1.72. and since this is coming away, it's coming from the bottom of the feet, and we want to find the distance, we'll subtract it by x, which is the distance that will be away from the center of gravity, as the question is telling us, away from the center of gravity of this person from the bottom of the feet. So that's the distance we want, so we'll subtract it from the distance that's away from this from the pivot, the 172. All right, and that will be equal to the second scale, the weight of the second scale, which is 31.6 times 9.8, and that will be multiplied by x. All right, that will be multiplied by x. So on this other side of the equation, when you do a calculation, the 35.1 times 9.8, that should give you 343.98. You still have the 1.72 there, minus x for now. Then this other side of the equation, you should get 309.68x. Okay, so expanding there, you should get 3. When you do expansion there, you should get 591. Let me write the 9 properly. 591 point. You don't need to round off. During the calculation, you do the round off, final answer. So this will be 343.98 times x, which will give us this, and that will be equals to 309.68x. Okay, so we can simply group the like terms. Alright, and if you group your like terms, you should get 5,196,456. In this case, will be equals to the addition of, let me go on the next board for more room. So we're saying the 591.6456 should be equals to the addition of 309.68x. This is 8x, which will be added to 343.98x. Okay, so when you add those like terms there, you still have the 95916,456 inside. The addition of these two like terms should give you 653.66x, and for us to find the value of x, which will be simply the distance of the center of gravity, which we want in this question, divide both sides of the equation by the 653.66, this side 53.66. Cancelling this side and doing the division there, you should get the value of x to be 0.91 meters, which is 91 centimeters. So this distance is simply the distance we're looking for. So this will be the distance of the center of gravity of this person from the bottom of our feet. So you guys, you can kindly share your views of how you thought of this question, the challenges you had, and you can tell us how best or any formula apart from this one that we can use to solve this question. Yes, and in the next video we'll be solving this question 10. You guys can go through it before we get into the solutions.